Hello and what's up, everybody? We're back for what might be our final geometry lesson of the year. Today we are talking about points on a circle and how to find out if a point is on a circle while in the coordinate plane. So let's start off by first using our information that we learned the other day by writing the equation of a circle using the information given. We're given our center and we're given our radius. So our radius is r and our center is h. Okay, so let's remember how we'd write this. Our equation for a circle is x minus h squared plus y minus k squared equals r squared. Now we just have to plug everything in. So we get x minus 5 squared plus y. The minus here and the negative 10 are going to make a plus 10 squared equals, and then we have to plug in our 10 and square it, which we then could just simplify. And I'm not going to want to rewrite this whole thing. So 10 squared, I'm just going to erase this, and we're going to write is 100. And there you go. You got your equation of a circle. And this is what we learned in our last lesson. So let's get going into our lesson today. Our lesson today is called a blip on a radar. We're going to be doing a lot with a radar. So think about radars that you may have seen in video games or radars in the army. And think about how it's all in a circular motion, right? And basically, if there's a blip on the radar, that's a point on a circle, and that's kind of what we're going to be talking about today. So we're going to use the Pythagorean theorem to determine whether a point lies on the circle on a coordinate plane, given the circle's center at the origin or not at the origin, the radius of the circle, and the coordinates of the point. Determine the coordinates of a point that lies on a circle given the location of the center point and the radius of the circle. So basically, we're going to see if we can find points on circles. So let's start with our first situation. It says peripheral vision. In a video game, like I said earlier, the locations of objects are tracked by radar using coordinates. And we have a little example down below. So our first one says 4 objects are represented on the circumference of the blue circle, which has a radius of 10 units. So I want to mark that off immediately. The radius right here is 10 units. Label the objects with their coordinates. Explain how you know. So if this is 10 units, now we're not moving up or down. And think about your x and y coordinates. X, y. Your x is your left and right coordinate. So are we moving left and right? And how many? And your y is up and down coordinate. So are we moving up and down? So for our first A, where are we going from 0, 0? We know this is 0. We're moving right 10, which is positive. So we could write our A as 10, and then we're not moving up or down, so it's going to be 10, 0. Now, the radius is true for all of these. So all these are going to just be 10 units away. For instance, if we go to B, we just go up 10. So it's going to be 0, 10. And then C, now we're going left 10. So negative 10, 0. And then last but not least, D, we're going down 10 from our origin, which is just 0, negative 10. Awesome. And now, our next part says, consider an object on the circumference of the blue circle, which is not located at one of the 4 points in the diagram. What is the minimum information that you need for the 4? Sorry. Let me start over. Consider an object on the circumference of the blue circle, which is not located at one of the 4 points shown in the diagram. What is the minimum information you need to determine the coordinates of the point? Justify your answer. Well, if we think about it, anywhere on this circle, let's say we choose this point right here. And I want to know, how do I get to that point, right? No matter what, if we go in a straight line to it, it's always going to be our radius here, right? And then we could always say that this distance here is going to be the x coordinate, right? This is my x coordinate. And then this distance will be my y coordinate, right? And this gives me a right triangle. So if we want to find out what this point is, we either need the x, the y, or our radius, or we need 2 of each. So we need x and y, That'll just tell us the coordinate. Or we need x and r, because then we could use those two in the Pythagorean theorem to find y. And last but not least, y and r, because then if we know those two, we can use the Pythagorean theorem to find x, right? So if we know these things, then we could always find the other. So let's get into the work now, because that's exactly the topic we're going to use, right? So right here it says, use the Pythagorean theorem to determine whether the point B, 4, 3, lies on the circle A, and then explain your reasoning. Well, if we think about it, where's 4, 3? 4, 3. If we look at the coordinate plane, we could see that it lies on the circle. But as I drew in the last picture, we could create a right triangle with our right angle being right here to look like this. And this is going to be R, also known as our radius, right? So what we could do is actually plug this in to our Pythagorean theorem. A squared plus B squared equals C squared, where C is going to be our R. So technically what we're actually doing here is using x squared plus y squared equals R squared, which is our circle equation at the origin, which is what we have here. We have a circle, and the center right here is at the origin, 0, 0. So we're just plugging these into the circle equation. So let's see. Our x is going to be 4 squared plus 3 squared equals, and what's my radius of the circle? Well, we go from 0, 0 to 5, 0 for p, so our radius is 5 squared. Let's solve this. We get 16 plus 9 equals, I meant to put a 5 here. 5 squared is 25. On my left side, 16 plus 9 gives me 25, which is equal to 25. This checks out. That means that 4, 3 is on the circle, which we already know, because it's right here. Point B is 4, 3. So now, let's test if 8, 15 is on my circle. And it says that we have the diameter of 34 units. So if the diameter is 34, we know that the radius is going to be 17. Whoops. Second guess myself there for a second. It's going to be 17. Because it's half of 34. So all we have to do, and since this is at our origin, since it's at the origin, the equation is going to be x squared plus y squared equals 17 squared. So then all we have to do is plug in our points for x and y. So 8 is going to be my x. So we get 8 squared plus 15 squared equals 17 squared. Now these are bigger numbers. I'm going to need a little bit of a calculator here. So we get 8 squared is going to be 64. I knew that one. I don't know why I plugged it into a calculator, but it never hurts. Plus 15 squared is 225. I know that one. I don't know what 17 squared is. I'm not going to lie. 17 squared is 289. So now we just have to add 64 and 225, and that's going to give me 289 equals 289. So is point 815 on the circle? Yes. Yes, it is. So 815 right here is going to be on the circle. And now one thing that we could do, because circles are symmetric, right? So if 815 is on the circle, we could then make our first one negative and say negative 815 is on the circle. And this works because we're at the origin, right? If we're not at the origin, this little trick won't work. We could then say that negative 8, negative 15 is on the circle. And last but not least, positive 8, negative 15 is on the circle. All of these points, check, 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 are on our circle here. So how can we do this when it's not at the origin is our next question. Well, like I said, we could use the equation of the circle to do that. And we just plug things in. But first, we need to find the equation of the circle. So we need to go back to yesterday, and we need to think about how do we write the equation of the circle. So it says, consider circle G with the center point located at 3, 0. This is my K, this is my H, and the point M at 3, 2. Now notice what changes from 3, 0 and 3, 2. It's my Y coordinate and it moves 2. That tells us that our radius is equal to 2, right? 3 and 3 are the same. 0 to 2 is plus 2. Nice and simple. That tells me my radius is 2. So now we could write our equation. Remember the circle equation. X minus H squared plus Y minus K squared equals R squared. So let's plug in the information we know. X minus 3 squared. I mixed these up. Should be HK. HK. Sorry, guys. Sorry about that confusion. Plus, now Y, this is 0, so we're just going to leave it as Y squared equals R squared, which is 2 squared. Or also known as 4. And all we have to do is plug in these numbers. Now you're like, oh, but mister, what's going on here? Well, this is why we use our beautiful, wonderful Desmos calculator, right? Because if you plug these in, it's going to give you simpler answers. So let's see what we get. So we get X minus 3 squared. And what we could do once we write this out, so let's write this out first. We get X minus 3 squared. So we really get 4.5 minus 3 quantity squared plus Y squared, which is square root of 3 over 2 squared. And we know that we want this to equal 4, right? We want this whole thing to equal 4. So what I'm going to do is I'm actually going to just take that. Use your Desmos calculator, people. I tell you all the time. And let's just plug it in exactly how it looks. So open parenthesis, 4.5 minus 3, close parenthesis. And we're going to do our square. Plus, open parenthesis, radical 3. Make sure you click outside of it, divide it by 2. Click outside, close it, and square it. And all we have to do is click enter. And what does it give me? It gives me 3. It gives me 3. Let me just move this back over to my other screen. And does 3 equal 4? No, 3 does not equal 4. So we could say point J is not on circle G. Point J is not on circle G. Why? Because when we plug it in, 3 does not equal 4. This point does not lie on the circle. That's simple. So all we did was we wrote the equation of the circle, which we learned in the last lesson. If you need a reminder, go back to the last lesson, deriving the equation of a circle, and then we plugged our points into that equation. It's that simple. Let's try another one. Same circle. I'm going to start scratch again. Here's our center, 3, 0, H, K. What's my radius here? Well, one way we could do it is we could also look at the graph and we could count. 1 is here. Look, be careful. Not each dash is 1. So we go 1, 2. Our radius is 2. And think of our standard equation. X minus H squared plus Y minus K squared equals R squared. So when we plug in our H and our K, we get X minus 3 squared plus, since our K is 0, this is just going to be Y squared equals 2 squared is going to give me 4. So now this is our equation for this specific circle. So if we want to know, is 4 radical 3 on this circle, we could plug it right in. So let's do that. So we get 4 minus 3 squared plus radical 3 squared equals 4. And I could actually do this math all myself now, right? This one's actually a simpler one. 4 minus 3 gives me 1. We get 1 squared. Plus, we could square this right now. Radical 3 squared, the square and the radical cancel. That just leaves me with 3 equals 4. What is 1 squared? 1 plus 3 equals 4. Is that true? 4 equals 4. That is true. Check. So we could say point P is on circle G. Yes, we did it, right? And just in case some of you are wondering, this is a check mark. Oops, messed it up again. Check mark. Yay, we did it. 4 equals 4. That is a true statement. So once again, we wrote the equation of our circle, which we already knew from the last problem. I just rewrote it again to refresh our brain. And that's right here. Our equation of our circle is this second line. And then we plugged in our new values, the points for P, 4, radical 3. And then finally we solved and we got 4 equals 4. So now, our last thing that we're going to do here, maybe our last thing, I'm not sure actually, is reasoning with circle symmetry. Right? So let's go here. And this is kind of what I talked about earlier. On a circle, you could find points of symmetry, no matter where it is. And if you have the graph like we have here, it makes it so much easier. Right? So it says circle C, with its center point located at 1, 5, and on a radius of 3 units represents the telescope's new mirror. The location of one of the mounting brackets is shown. Determine the coordinates of the mounting bracket shown. Well, that's easy. We can use our grid for that. So we go here. We know it's going to be at 3. 3 point and probably 7.25. So it's going to be at 3, 7.25. Comma 7.25. There's our units. 3, comma 7.25. Now, how do we know if this is definitely true? Well, we could go through the process of writing out our equation, right? Of the circle, which is going to be x minus 1 squared plus y minus 5 squared equals, what's our radius here? It's going to be 1, 2, 3, 4, 5, 6. So it's 6 units. Actually, did I miscount? I did. 1, 2, 3. Okay, so it's going to be 3 units because these are double dashed, right? So 3 units, which is going to give me 9 here. What we could do in a calculator, so let me get my Desmos calculators, we could just plug this in. And we want to say, hey, if I plug in these two numbers for x and y, will my left side be 9? So let's try. Open parenthesis, 3 minus 1, close parenthesis, square it, plus, open parenthesis, 7.25 minus 5, close parenthesis, square it. What does it give me? It gives me 9.0625. So what we could see is it gives us about 9. And for this problem, that's okay. This is going to actually turn out to be what we want. So we could say, yes, it gives me 9, right? So it works. So now, what do we do from here, right? Now, it says, use symmetry to identify the locations of the other 7 mounting brackets on the mirror. I know that's a little cut off, but that's what it says. Well, what we could do is then this. We know that there's going to be mounting brackets up top, perfectly up top, perfectly to the right, perfectly to the left, and perfectly to the bottom. And now what we have to do besides that is look, if we go 1, 2, 3, 4 lines over, not total units, it's 2 units over, and then 1, 2, and like a half units up, right? Let's do that again. 1, 2, 3, 4. 1, 2, 3, 4, 5. We'll get these center points. And we could do that for the other ones. 1, 2, 3, 4, 1, 2, 3, 4 and a half. Ready? And then 1, 2, 3, 4, 1, 2, 3, 4 and a half. And we got our symmetrical points, all by using this pattern, but just adjusting the directions for it, right? Now, if we want, we could also go forward and we could find the coordinates for all these. Right now, I think you guys should be able to find coordinates, so we're not going to write it here. But this is exactly how you find it. And now we're getting to our last couple of problems. So let's check it out. All right, for our next slide, we have a system of equations. The way we could do this is by substituting. So this is something you guys learned in Algebra 1, but a lot of people probably forgot. But we should all remember how to substitute. Well, it's the same when we have equations. Notice our second equation is equal to, it says y equals something. We could substitute that in for y up here, and this is how we're going to do it. Let's start off by writing our top equation. We get x squared plus, and now we hit our y. Instead of writing that y, we're going to write what's after this equal sign. 2x minus 20 squared equals 100. But now we need to remember, how do we square this? Well, when we square this, I'm going to save us all the work. You get 2x times 2x, which will be 4x. You get 2x times negative 20, but then you'll have a negative 20 times 2x. Basically, it's going to give us a negative 80x. And then finally, negative 20 times negative 20 will give me plus 400 equals 100. And this is what happens, right? Oh, sorry, this should be 4x squared. I almost forgot. Now we could simplify. We got 5x squared minus 80x plus 400. Actually, we're going to bring this 100 over, right? We're going to subtract 100 from each side. And the reason we're going to do this is because we want a 0 on this right side, which will give me 300 here equals 0. And now what we could do is we could divide all these by 5. That'll give me x squared minus 16x plus 60 equals 0. And now what we could finally do is factor this, and we'll get x. What two numbers multiply to give us 60? A positive 60, but give us a negative 16. They both have to be negative in order to give us this positive when they multiply. So we'll get negative 10 and x minus 6. So think about it. Negative 10 times negative 6 will give me positive 60. But if we add negative 10 and negative 6, it'll give me a negative 16. And this equals 0. So now finally we could split these up. We could get x minus 10 equals 0. X minus 6 equals 0. This is going to tell me x equals 10 and x equals 6. Now last but not least, we need to put these in to get our y coordinate. Right? So we're going to use this bottom equation. We put 10 in here. 10 times 2 will give me 20. 20 minus 20 will give me 0. Put the 6 in there. 6 times 2 will give me 12. 12 minus 20 will give me a negative 8. And there's our two coordinates. Let's try out the next one. Once again, we got to substitute again. X plus 5 squared, that stays the same. This is, now we hit our y, we substitute in, plus x minus 3 squared equals 64. Now this time we have to do two FOIL methods, one for each of these. So my first one is going to give me x squared plus 10x plus 25. My second one will give me plus x squared minus 6x plus 9 equals 64. Now we got to add this all up. Combine like terms, we got x squared plus 4x plus 34 equals 64. Now we need to subtract the 64 over. We'll get x squared equals 4x minus, that's going to give me 30 equals 0. So now we need two numbers that will give me a negative 30, but when we add them together, they multiply together to give me negative 30, but we add them together to get a plus 4. That is the question. I actually made a mistake. There should be a 2 in front of this. A 2 in front of this. We divide everything by 2. We got x squared plus 2x minus 15 equals 0. And now we factor this. And when we factor this, we get x plus 5, x minus 3 equals 0. We can set both of these equal to 0, which will give me x plus 5 equals 0. X minus 3 equals 0. Oops. Which then means subtract 5 from both sides here. We'll get x equals negative 5. And x equals 3. We can write that in coordinate form. Negative 5, comma, and we'll find our y. And then 3, comma, and we'll find our y. If we plug it in up here, negative 5 minus 3 will give me negative 8. 3 minus 3 will give me 0. Awesome. Second system of equation done. So this is the end of our lesson. I know that the system of equations can be a little confusing because there's a lot of previous work, and some other things may have been a little confusing throughout this lesson. Don't be afraid to ask for help, but also don't be afraid to use this as a jump off point to maybe search for another video or whatever else you have to do. But remember that your teachers are here to help you, so don't be afraid to ask for help if you need it. And thanks for learning today.